ratio of average kinetic energy of 14 gram of nitrogen at 27 degrees Celsius to 24 gram of oxygen at 227 degrees Celsius is. It means we have two different gases we are talking about, and in these two gases we have different temperatures also. We just have to find out the ratio of average kinetic energy of these two gases. So one thing we should know, that whenever we talk about the average kinetic energy, the simple formula that we use here is N into 3 by 2 RT. This is the formula that we use. Now, first we have the gas, that is nitrogen. What is the moles of nitrogen? Given mass is there, that's why we can easily find out the number of moles. So let's find out the average kinetic energy for nitrogen. What would be it? It would be 14 by 28, the number of moles, into 3 by 2 into R, and what's the temperature? That is 27 degrees Celsius. So it is 300 Kelvin. So this is the temperature that we have taken here. Further, what would be the kinetic energy for oxygen gas? That would be given mass, that's 24, divided by its molar mass, that's 32, 3 by 2 into R, and what's the temperature here? That is 227 degrees Celsius. What would be the temperature in Kelvin? That is simply 500 Kelvin. So what we need here, we need the ratio of these two. So kinetic energy for N2 upon kinetic energy for O2 is equal to, we cut here, this is 1 by 2. This would be 3 by 4. Now, in this case, we can write it as 1 by 2 into 3 by 2 into R into 300. This is the first expression, and divided by the second one, that is 3 by 4. Further, 3 by 2, then R into 500. This is the final expression that you are going to take here. And if you solve this, you will find out that this ratio is 2 by 5. So what would be the correct ratio of the average kinetic energy of nitrogen and oxygen, the given amount we are considering here? That is given in option 2, 2:5. And that's why you should choose the correct answer, that is option 2. Question number 57. If the energy absorbed by each X2 molecule of a gas is 3.5 into 10 to the power minus 19 joule, and the bond energy of X2 is 180.6 kilojoule per mole, then the kinetic energy per atom will be. So we are just going to talk about that particular gas which has the molecule X2. It means diatomic molecule is there, and what is given in the question? In the question, the total energy absorbed by each X2 molecule is given, that is 3.5 into 10 to the power minus 19 joule, and the bond energy of X2 is also given, but that is 180.6 kilojoule per mole. So it is given in kilojoule per mole. It means 1 mole requires 180.6 kilojoule energy as the bond energy. And if you want to find out the kinetic energy, that you can find out by the simple formula, that is equal to the total energy absorbed per molecule minus bond energy per molecule. But they are not asking about the total kinetic energy, they are asking about the kinetic energy per atom. And if the molecule is diatomic, so kinetic energy for one atom, or simply the kinetic energy per atom, can be found out by dividing this value, whatever you are obtaining here, dividing it by 2. So first, let's check what is energy absorbed here. That is the total energy absorbed per molecule. It's clearly given in the question, that is 3.5 into 10 raised to the power minus 19 joule. But if we talk about the bond energy, per molecule, it would be equal to 180.6 kilojoule per mole. It means it should be divided by Avogadro number to find out per molecule. And this value we need in joules, not in kilojoule. That's why I'm just going to multiply 1000 here. And this is the bond energy per molecule. So let's find out the kinetic energy per atom. That is equal to the total energy absorbed, 3.5 into 10 raised to the power minus 19, total energy absorbed per molecule, minus. If you solve this, you will find out that this value is equal to 3 into 10 raised to the power minus 19 divided by 2. And if you solve this, you find out this value is 2.5 into 10 raised to the power minus 20 joule. So this is the kinetic energy per atom. And if it is so, the correct answer is given in option 3. So the answer you can choose for this question is option 3. Let's check next question. Question number 58. The ratio of average speed, most probable speed, and root mean square speed of a gas sample will be. A very good question from states of matter, the simple one, because we just have to compare the formulae only. So first is the average speed, then most probable speed, and then RMS, root mean square speed. Consider these values. Then this formula for average speed is root 8 RT by pi m, then root 2 RT by m, most probable speed, then root 3 RT by m. So this we have here. And if you compare this, you will find out that this is root 8 by pi, then root 2, then root 3. The simple comparison of these three. And on that basis, we can easily choose this option. That's option 2 as our correct option. Let's check next question. Question number 59. The bond energy of HH and II bonds are 435 kJ per mole and 150 kJ per mole respectively. If delta H in standard condition for the formation of HI is 26.5 kJ per mole, then bond enthalpy of HI bond is. So first we need to check here that how this HI is formed. It is formed by combination of H2 and I2, we all know. It's forming HI, and that we can also represent as this. And if you want to find out the enthalpy for a certain compound, that is equal to sum of the bond enthalpy for the reactant minus sum of the bond enthalpies for the products. Let's place the values given here in this particular equation. This delta H value is given 26.5 kJ per mole. That should be equal to the sum of the enthalpies of the reactant. So what are the reactants here? Hydrogen and iodine. So we'll take its bond energy for hydrogen as half of 435 kJ per mole plus half of 150 kJ per mole. This is the bond energy for reactant minus bond energy for the product. What is that product? That is HI. So definitely the bond enthalpy for HI bond, that is product, is equal to half of 435 plus 150 minus 26.5. 5. And if you solve this for the final answer, you will get 266 kilojoule per mole. And that's why I just mark option 2 as the correct option. I hope this question is clear to you. Let's move on to the next question. Question number 60. Select the state functions among the following. We have the first U plus PV, then entropy, Q heat, W work done, then H minus TS. So in this case, you should know that when we talk about U plus PV, it is a state function. I'm just writing here SF for state function. Entropy, this is also a state function. Q is a path function, not the state function, it is a path function. And W is also the path function. Then H minus TS is also state function. So I have segregated the state function and the path function. On that basis, which answer is correct? Definitely option 2 is the correct option. And that's why answer for this question is option 2. Let's check the next question.